Okay, here we are. Lesson 6, Chapter 2, Ratios and Proportions. If I'm being honest, there's a good chance you probably don't need to watch this video in order to do this lesson, but for the sake of just being thorough, let's do this. Okay, so a ratio is a comparison of two numbers by division. You can show that as a fraction bar like they do right here. You can show it with a colon separating the two numbers. You can actually write x to y using the word to as in to. Okay, if we have two ratios that we know are equal, it actually creates a proportion. Okay, so the first types of questions is they're going to ask you if two ratios are equivalent. All right, well, it's pretty basic. There's a couple different ways you can do it. You can start by just reducing both of them down. Like this one, 3/4 is already reduced. 15/20, we can divide both of those by a 5. So divide by 5, and you get 3/4. And they are equal, so the answer is yes. And it says, justify your answer. I would say that this is justification enough. You're showing me that. Okay, another way to do it, besides reducing one of them, is to try cross products. And we'll get into that just below here, but that's another way. So as we get to the next part, you can always try that on your homework as well. Over here, though, I'm going to divide these both by 7 because I know 7 goes into both of them. And looky there, it is 7/8. So yes, that one is also equivalent. All right, so as I was talking about with proportions, if we have two ratios that are equivalent, they create a proportion when we set them equal to one another. Okay, so the means will always equal the extremes, and I love the way they have it set up here. This is taken right out of your book. The means would be the first number of the first ratio and the last number of the second. The product of those two, those are the extremes, sorry. And then the inside ones, the 1.5 and the 1.2. If I'm showing that as a proportion written like this, 0.2/1.5, and then, 1.2/9.0, that would mean these two are the extremes, and these two are the means, and they will always be equal to one another. So we can use that, and right here, here's your hint. Another way to determine if two ratios are equal, well, then just check your cross products. If the cross products are equal, then you know they're equivalent. Okay, so now we're going to do that down here, checking with cross products. You can go ahead and use your calculator if you think you need to, but this first one, 0.7 times 3.0, that is, I think I know it, but I'm going to double check it, is 2.1, right? And then 0.8 times 2.8, I know it's not equal, but I'm not sure. 2.24. So because they're not equal, these are not a proportion. They are not equivalent to one another. Same thing on the second half, 12 times 9. Well, 12 times 9 I know is 108. 6 times 18 I'm pretty sure is also 108. So that one is a yes. Okay, besides determining if two ratios are equivalent, we're going to use a proportion to solve for a missing measure. Okay, so on the back, super cool. This one's really cool, and we're going to get to that one, but I want to do this one first. I'm sure you've all heard the phrase cross multiply and divide. It comes from the means and the extremes, because we know that 12 times 3 is going to be the same as 8 times n. And 12 times 3 is 36. And then when we divide by 8, it's not going to go in there perfectly, but I'm pretty sure it's 4.5. Then that's the same thing. Now, if it's the same thing if I were to cross multiply and divide, because I'm multiplying 12 times 3, and then I end up dividing by 8, which is my coefficient. So the cross multiply and divide is really the same thing as setting your means equal to your extremes. Now, if it's like that, I can just cross multiply and divide and solve. But take a look at this proportion. All right, now in this one, I can't just cross multiply and divide because I don't just have a variable down here in the denominator. I have an expression. So here's what we do. We still set our means equal to our extremes. So I'm going to have 5 times 6, which is, I'm just going to leave it 5 times 6 right now. Sorry. And I'm set that equal to 12 times k plus 1. All right, now I've got an equation. So I've got 30 equals, and then I'm going to use my distributive property, 12k plus 12. And I have a two-step equation. So minus 12. I get 18 equals 12k, divide by 12, and I'm pretty sure that is 1 1/2. You can double check me if you think I'm wrong. Okay, so we're going to see problems like this on your assignment where you can't just cross multiply and divide. You actually have to write out the equation so that you can solve it. All right, so on to more things with proportions and ratios is the term rate is called when we have different units of measure. Okay, so a ratio with two measurements having different units are called that a rate. Okay, and then a unit rate is when it's always over 1. So here's just an example of a rate, $9.99 for 10 songs. And then a unit rate just means that the denominator is always a 1, so 30 miles per 1 gallon. Okay, we can solve these problems in two different ways. We can solve it by finding a unit rate and multiplying, and let me show you that. So Brandy paid $6.75 for 3 pounds of mixed nuts. At this price, how much would she pay for 5 pounds? Okay, well, I could find a unit rate, meaning $6.75 divided by 3 pounds. If I divide that out, I'm going to get $6.75 divided by 3. Oh, why did I use my calculator? See, now I'm turning it to you guys. $2.25 per pound. Okay, so then all I have to do is take that times 5. So 225 times 5 is going to give me 1125. So I can use a unit rate to solve this problem. Here's the cool part. I can also use a proportion. I could have set up a proportion. I'm going to set it up over here, saying, well, if $6.75 buys me 3 pounds, then how much money will buy me 5 pounds? And you cross multiply and divide. So 6.75 times 5, and then divide that by 3, and you will also end up with 1125. Either one of those processes will work. Okay, same thing for the next exercise. It takes 7 minutes for Bella to walk around the gym track twice. At that rate, how many times can she walk around the track in a half an hour? Again, I could make that a unit rate. 7 minutes gives me 2 laps, I'll call them. So I know it's 3.5 minutes per lap, right? But this one isn't as cozy, you know, it's not as nice to just figure this out. Okay, if it's 3.5 minutes per lap, and now I know 30 minutes, you have to know that then we divide by 3.5 minutes per lap. And you get not an even number. You get, and that's why it says round to the nearest tenth. So you get 8.57, so 8.6 laps, right? So that one's not quite as pretty, and you do have to understand that. So you can do this. 7 minutes gives me 2 laps. So 30 minutes will give me how many laps? Cross multiply and divide, and you will get the same answer. You do not have to show me both ways. One way is fine. The very last type of question you will see on your assignment today is dealing with a rate that is a scale. Okay, if we just have a scale, that means you have maybe have something that's really, really, really big or really, really, really small. It's either too large to show or too small to show, so that you might draw a scale or a scale model. So that's like a three-dimensional reproduction of something, okay, whether it's a big, like if you've ever been to the ear doctor, they always have like a three-dimensional model of the inner ear, which is itty-bitty teeny pieces, but it's bigger. So same idea. With that, they always draw them in a scale. We can use the proportions and the ratios to solve questions using scales. Take this for example. Jane wants to make a doll that is a replica of a friend. Aw, it's a little sweet and maybe creepy. But the scale that she will use is 1 centimeter on the doll will represent 2 inches on her friend. Her friend's foot measures 8.5 inches. What will the size of the doll's foot be? Now, honestly, I set this up as a proportion, and this is how I think. And I use my units to help guide me. I say, okay, well, 1 centimeter on the doll, and I'll just write doll up here, and then friend gives me 2 inches on my friend. So we got the friend's foot size is 8.5 inches. See how I put that in the bottom? I want to figure out just how big on the doll that's going to be. If I solve that, I've got 2x equals 8.5, and when we divide by 2, should get 4.25, and this is centimeters. That is one way to use the scale that they gave me right here to solve that with a proportion. Okay, you will get a green sheet for your homework, and hopefully you do well on it. Best of luck. I'll see you guys tomorrow or whenever I see you. Thanks.